matrices, types of matrix. Next one, diagonal matrix. Diagonal matrix. Diagonal matrix. Diagonal matrix means in a square matrix, if each non-diagonal element, that is non-principal diagonal elements, already we know that principal diagonal elements. If each non-principal diagonal elements is equals to the zeros, non-principal diagonal elements is equals to the zero, then the square matrix is called diagonal matrix. In a square matrix, if each non-diagonal elements, already we know that non-diagonal elements means non-principal diagonal elements, right here, non-principal diagonal elements is equal to 0, is equal to 0, then the matrix is called, diagonal matrix. Diagonal matrix. Observe here, in a square matrix, if each non-principal diagonal elements, already we know that principal diagonal elements, if each non-principal diagonal elements is equals to 0, then the matrix is called what? Principal diagonal matrix. Then the matrix is called what? Principal diagonal matrix. Let us discuss one example here. Observe here. That is example. Principal diagonal elements is observed. 1, 0, 0, 0, 2, 0, 0, 0, 3. This is a diagonal matrix. Diagonal matrix. Why? Because observe here. This is a clearly square matrix, order 3. That is 3 by 3. 3 rows and 3 columns. That is order is how much? Order 3. Observe here. This is a square matrix. If each non-principal diagonal elements, these are principal diagonal elements, non-principal diagonal elements means this is, if you accept this principal diagonal element, remaining all the elements are called non-principal diagonal elements. Non-principal diagonal elements equal to 0. Observe here, this is not principal diagonal element, this is not principal diagonal element, this is not principal diagonal, this is equal to 0. Then the square matrix is called diagonal matrix. Then the square matrix is called what? Diagonal matrix. And the square matrix A is A. When a square matrix A is A, order n is called the diagonal matrix if A is equals to 0 for I is not equals to 0. Then only observe here. If a square matrix A is A, order n, order n. This is a square matrix. A is equals to A is a square matrix. Order n is a diagonal matrix. If and only A is equals to 0. A is element 0 for I is not equals to 0. For I is not equals to 0, then the element value how much becomes to 0. Then the matrix is called diagonal matrix. Then the matrix is called what? Diagonal matrix. Observe here, this is A11 element. Clearly, A11 value 1. This is A12 element. A12. I is not equals to Z. I is not equals to Z. Here value 1, Z value 2. I is not equals to Z. Then the element value clearly is 0. This is element is A13. A13 value number 0. Observe here, if I is not equals to J, A is a value 0. I is not equals to J, A is a value 0. Clear? Also, A12 A21 value also, A21 value 0. A21 value 0. Now I am discussing principal diagonal elements. Principal diagonal elements either 0 or 1, any scalar. Not at all. This elements not zeros or any real numbers. But only non-principal diagonals only I will discuss. Non-principal diagonals. Non-principal diagonals only zeros. What about principal diagonal elements? Principal diagonals I will not discuss. That is either zeros or either any real numbers. So I will not discuss that principal diagonal. Only I will discuss non-principal diagonal elements. Non-principal diagonal elements will become zeros. Observe here. This is A21 is equal to 0. A22 clearly 0 or any real numbers. But A23 value is 0. This is for I not equals to z. I not equals z. A is a value 0. So this is a diagonal. Also A31 equals to 0 also. A32 is equals to also 0. A matrix, square matrix A is a order n is called a diagonal matrix. If and only if A is a value 0. A is a value how much? 0. For I not equals to z. I not equals to z. A is a value 0. I not equals to z. A is a value 0. I not equals to z. A is a value 0. I not equals to z. A is a value 0. So that's why that matrix is called what? Diagonal matrix. Diagonal matrix is what? In a square matrix, if each non-principal diagonal elements are equal to 0, non-principal diagonal, this is the principal diagonal element. Non-principal diagonal elements are zeros. Then the matrix is called what? Diagonal matrix. Next, scalar matrix. Next one. Scalar matrix. Scalar matrix means if a square matrix, if each non-diagonal elements, if each non-diagonal elements or diagonal elements of a square matrix, is 0 and diagonal elements is equal to the scalar, some constant k, then the matrix is called scalar matrix. That means scalar matrix means in a square matrix, if each non-principal diagonal element, principal diagonal is nothing but diagonal elements. Non-principal diagonal elements is equal to 0 and the principal diagonal elements is equals to principal diagonal elements is equals to a scalar k is equals to a scalar, some constant, that is some scalar k, then the matrix is called scalar matrix. Observe here. If a matrix in a square matrix, if each principal diagonal elements, if each non-principal diagonal elements is equal to zeros and principal diagonal elements is equal to some constant scalar k, then the matrix is called scalar matrix. What? Scalar matrix. Observe here, this diagonal matrix also denoted by diagonal of 1, 2, 3. Diagonal of 1, 2, 3. Diagonal of 1, 2, 3 means principal diagonal element. This is 1, 2, 3. Remaining all the elements is zeros. So this is also denoted by this. Scalar matrix means non-principal diagonal elements are zeros and principal diagonal elements are is equals to some constant k. Some constant, that is some constant scalar k. Then the matrix is called what? Clearly scalar matrix. If you take one example, that means how we take this is if A is equals to A is a order n. Order n. If A is equals to A is a order n is a scalar matrix. Is a scalar matrix if and only if A is equals to 0. A is equals to 0 for I is not equals to j. A is equals to 0 for I is not equals to j. And A is equals to k, some constant k. A is equals to some constant k for I is equals to j. For I is equals to j. Then the matrix, then the scalar matrix is called what? Then the matrix is called scalar matrix. For example, if you take one example, that is A is equals to 4, 0, 0, 0, 4, 0, 0, 0, 4. This is a scalar matrix. Observe here, this matrix, non-principal diagonal elements, values zeros. The principal diagonal elements is equals to some constant, that is k, that is 4. So this is called what? Scalar matrix. Every principal diagonal element is equal to 4 is equal to some constant k, or that is A is equal to 2002. This is a scalar matrix order 2. This is a scalar matrix order 3. And take any number. Some principal diagonal elements is equals to some constant k, and non-principal diagonal elements is equals to zeros. Then the matrix is called what? Scalar matrix. This is scalar matrix order 3. This is also scalar matrix order 2. This is 2002. This principal diagonal element is equals to 0. Non-principal diagonal elements is equals to zeros. Then the matrix is called what? Scalar matrix. Observe here. A matrix Aij is called a scalar matrix if A is a value 0. A is a value, that is A is the element value 0 for I not equals to j. The values are equals to zeros, and A is a value equals to some constant. For I is equals to j. That means A11 element. I is equals to A11. Observe here, 1 is equals to 1. So I is equals to the element value is equals to some constant k. 4, A22, A33 is equals to some constant k. Then the matrix is called what? Scalar matrix. Next types of matrix only. That is unit matrix. Next type. Unit matrix or identity matrix. Unit matrix or identity matrix. Unit matrix or identity matrix means, if already we know that square matrix. So in a square matrix, if each non-principal diagonal elements, in a square matrix, already we know that square matrix, in a square matrix, if each non-principal diagonal elements is equals to zeros, and if in a square matrix, if each non-principal diagonal elements are equals to zeros, and principal diagonal elements are equals to some constant 1. Principal diagonal elements are equals to some constant, how much? 1. Constant 1. That is, principal diagonal elements are equals to 1. Then the matrix is called. Unit matrix. Unit matrix are identity matrix. Observe here, in a square matrix, if each non-principal diagonal elements is equals to 0, and principal diagonal elements are equal to some constant 1. Some constant, always 1. Always principal diagonal elements equals to 1. Then the square matrix is called. What? Unit matrix or identity matrix. That means if you take one matrix, A is equals to order n. That is, A is equals to order n. Is a square matrix. So it is a unit matrix. Means this is a unit matrix. If and only A is a value 0 for I is not equals to Z. A is a value always 0 for I not equals to J. I is not equals to J, and A is a value 1. Always A is a value 1 for I is equals to J. Observe here, some compact form, that is general form. A is equals to A is a square matrix order n. This is denoted unit matrix if and only if. This is represent unit matrix if and only if A is a value 0. A is a value 0 for I not equals to J. If I not equals to J, observe here, if I not equals J, A is a value 0. A is a value 0 is nothing but A I not equals J means non-principal diagonal elements value zeros, and A is equals to 1 for I is equals to J means principal diagonal elements is equals to some constant 1. Always 1. A is a value always 1 for I equals to J. Then the matrix A is equals to order n is called what? Unit matrix. Is called what? Unit matrix or identity matrix. Unit matrix or identity matrix. Observe here. Identity matrix or unit matrix order n is denoted by clearly, that is IN. Identity matrix is denoted by unit matrix is denoted by I. So it is clearly the order is n, so it is denoted by IN. Let us discuss some more examples here. So identity matrix order 2 clearly. 1 0 0 1. 1 0 0 1. Identity matrix or unit matrix. Unit matrix order 2 is clearly 1 0 0 1. 1 0 0 1. Observe here. Principal diagonal elements are equals to some constant 1, and non-principal diagonal elements are equals to always zeros. Observe here. This is a identity matrix or unit matrix order 2. Say identity matrix or unit matrix order 3. I3 means what? Identity matrix or unit matrix order 3 is not divided. Observe here. 1 0 0 0 1 0 0 0 1. This is a unit matrix or identity matrix order 3. Unit matrix or identity matrix order how much? 3. Observe here. 1 0 0 0 1 0 0 0 1. Non-principal diagonal elements are equals to zeros, and principal diagonal elements. Principal diagonal elements is equals to some constant 1. Always 1. Observe here. 1. So this is a what? Unit matrix or identity matrix. So I4 means identity matrix order 4. Identity matrix order 4 is equal to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 0 0 1. This is a identity matrix order 4 or unit matrix order 4. Observe here, principal diagonal elements is equal to some constant 1 and non-principal diagonal elements is equal to zeros. So this is a unit matrix or identity matrix order 4. It is denoted by I4. This is unit matrix or identity matrix. Observe here, sir, this is not a scalar matrix. Yes, it is also a scalar matrix, but specific name is that is the identity matrix. So all the identity matrix are scalar matrix. All the identity matrix are scalar matrix. All the identity matrix are diagonal matrix also. But specific name is there, but all the scalar matrix, all the diagonal matrix, not always unit matrix. If principal diagonal elements is equals to 1 means then the scalar matrix is called as unit matrix or identity matrix. So all the unit matrix or identity matrix are scalar matrix, but all the scalar matrix need not be a unit matrix. This is also scalar matrix. Also specific name. What is that? Identity matrix or unit matrix. This is unit matrix or identity matrix. In the types of matrix only, that is triangular matrix. Triangular matrix. Triangular matrices there are two types. Triangular matrices are two types. First one is upper triangular matrix and lower triangular matrix. Upper triangular matrix and lower triangular matrix. First one, upper triangular matrix. Upper triangular matrix. Upper triangular matrix means a matrix is called upper triangular matrix. A matrix is called upper triangular matrix. A matrix is called upper triangular matrix if all the elements below the principal diagonal. First of all, we discuss upper triangular matrix. A matrix is called the upper triangular matrix if all the elements below the principal diagonal, observe here, the matrix is called upper triangular matrix if all the elements below the principal diagonal are equal to 0. Then the matrix is called what? Upper triangular matrix. A matrix A is equals to order clearly n by n is a upper triangular matrix if and only if if and only if Aij is equals to 0. Aij is equals to 0. Aij is equals to 0 for I is greater than z. Aij is equals to 0 for I is greater than j. I is greater than j, then the elements Aij is equals to 0, then the matrix is called what? Upper triangular matrix. Observe here, a matrix Aij order n or n by n is a upper triangular matrix if and only if A is a value 0, A is a value how much? 0. For I is greater than j. For I is greater than j, the element value how much? 0. Then the matrix is called what? Upper triangular matrix. Then the matrix is called upper triangular matrix. Let us discuss one example here. Observe here. Matrix. This is, if you take 3 by 3 matrix, 3 by 3 matrix out of 3, that is 1, 2, 3, any elements 1, 2, 3, 0, 4, 8, 0, 0, 3 or 0, 0, take any element that is minus 5. Observe here, this is a upper triangular matrix. This is a upper triangular matrix. This is clearly A11 element not equals 0. A12 means I is less than j. If I is greater than j, then the value is clearly 0. So not at 0. This is observe this. Or observe this. The matrix is called the upper triangular matrix. All the elements below the principal diagonal, the values is zeros. All the elements zeros below the principal diagonal. This is the principal diagonal. Clearly we know that this is principal diagonals. Below the principal diagonals, the element values is zeros. Then the matrix is called what? Upper triangular matrix. Observe here, clearly it will form one triangle. This is upper triangular matrix. This is upper triangular. It will form one triangle, that is uppercase. So this is upper triangular matrix. Upper triangular matrix. Take another example, that is, take B is equals to 1, 7, 0, 3, 0, 5, 4, 2, 0, 0, 8, 1, 0, 0, 0, 6. This is also, observe here, this is also how much? Upper triangular matrix. Below the principal diagonal, all the elements is zeros. Below the principal diagonals, all elements become zeros. What about above the principal diagonals elements? It will be zeros are any real numbers, but below the principal diagonal, all the elements values becomes 0. Then the matrix is called what? Upper triangular matrix. Observe here, A is order n. The matrix A is order n is a upper triangular matrix if and only if A is a value 0 for I is greater than j. A is a value 0 for I is greater than j. Then the matrix is called what? Upper triangular matrix. Observe here, it will form one upper triangle. That is. So this is called what? Upper triangular matrix. Next, second one is lower triangular matrix. Lower triangular matrix means a matrix is called lower triangular matrix if all the elements above the principal diagonals will become zeros. All the elements above the principal diagonal value is zeros. Then the matrix is called clearly lower triangular matrix. Or a matrix A is a order n is a lower triangular matrix if and only if A is equals to 0 for I is less than j. Then the matrix is called what? Lower triangular matrix. Observe here, lower triangular matrix is a matrix is called lower triangular matrix. Lower triangular matrix. A matrix is called lower triangular matrix if all the elements above the principal diagonal, above the principal diagonal is equals to 0 or equals to 0, then the matrix is called lower triangular matrix. Above the principal diagonal, all the elements value 0. Above the principal diagonal, all the elements value 0. If you take one matrix, A is equals to order n is a lower triangular matrix. If and only if A is a value becomes 0. For I is less than j. For I is less than j, A is a value 0. I is less than j. Observe, this is very important. A is equals to 0. For I is less than j, then the matrix is called lower triangular matrix. A is equals to 0. For I is greater than j. Then the matrix is called upper triangular matrix. A is equals to 0 for I is greater than j. Then the matrix is called what? Upper triangular matrix. If A is a value is equals to 0 for I is less than j, then the matrix is called what? Lower triangular matrix. Where do you write it? A is equals to order n is a lower triangular matrix if and only if A is a value 0 for I is less than j. For I is less than j, the value is always 0. Then the matrix is called what? Lower triangular matrix. Observe here an example. If you take matrix that is this is the principal diagonal element. Above the principal diagonal elements always zeros. That means take 1 0 0 0 take 0 2 0 3 2 1. Observe here. This is square matrix order 3. This is principal diagonal elements. Above the principal diagonal, the elements value is always 0. So this matrix is called what? Lower triangular matrix. Here also it will form one triangle, that is lower triangular matrix. Observe here, it will form one triangle. So this is lower triangular matrix. Take another matrix. So B is equals to 1 0 0 0 2 0 2 8 0 0 4 3 2 0 8 minus 5 3 1. Observe here, above the principal diagonal, this is principal diagonal. Above the principal diagonals, the elements become 0. This matrix is called what? Below lower triangular matrix. That means the elements. A matrix is said to be lower triangular matrix if all the elements above the principal diagonal value is zeros. Or a matrix A is a order n is said to be lower triangular matrix. A is a value 0. A is a value always 0. For I is less than j. Value is always 0. Observe here. This is A12 matrix. A12. This is A12. I is less than j. The value is 0. A13. I is less than j. The value is 0. A14. I is less than j. The value is 0. This is 2 3 elements. This is 2 3 elements. I is less than j. The value is 0. This is 2 4. For I is less than j. The value is 0. This is 3 4. The I is less than j. The value is 0. If I is less than j, I is a value 0, then the matrix is called what? lower triangular matrix. If A is equals to 0, if I is greater than J, then the matrix is called what? Upper triangular matrix. Upper triangular matrix. So if you take identity matrix, order 3, already we know that identity matrix or unity matrix, that is order 3, or 0 matrix or null matrix order 3. This is also both upper triangular matrix and lower triangular matrix. Both upper triangular matrix and lower triangular matrix. Why? Because if you take I3, that is matrix, unity matrix I3, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Observe here, this is a unity matrix. Here below the principal diagonals, all the elements zeros, and above the principal diagonals, all the elements zeros. So this matrix is called what? Both upper triangular matrix and lower triangular matrix. This is I3 is a, or I4 or I5, I6 is a both upper triangular matrix as well as lower triangular matrix. Also null matrix. If you take null matrix 0, 0, 0, 0, 0, 0, 0, 0, 0. If you take null matrix order 3 or order 4, order 5. If you take null matrix order 3, clearly observe here, this is a null matrix order 3. All the elements above the principal diagonals, above the principal diagonal is zeros, and below the principal diagonal is also 0. So I3 or identity matrix and null matrix or 0 matrix always upper triangular matrix as well as lower triangular matrix. Upper triangular matrix as well as lower triangular matrix. Why? Because A is a value 0 for I greater than J and A is a value 0 for I less than J. It will satisfy both conditions. So unity matrix and null matrix or 0 matrix always upper triangular matrix as well as lower triangular matrix. How to compare two matrices means, observe here, comparable matrices. Comparable matrix. How to compare two matrices means, two matrices are comparable if and only two matrices. Two matrices are comparable. Two matrices are comparable if and only their orders must be same. Their orders must be equal. If and only if their orders must be equal or same. Then only two matrices are comparable. How to comparable two matrices means, if two matrices order must be equal, then only we compare. Otherwise, not at all compare. For example, if A is equals to order m by n and B is equals to B is equals to order P by Q. If two matrices A is equals to order m by n and B is equals to B the matrix order is P by Q are comparable if and only if m is equals to, that means number of rows in first matrix is equals to number of rows in second matrix, and number of columns in a first matrix, number of columns is also equal to number of columns in second matrix. Then only the two matrices are comparable. Otherwise, not at all comparable. That means if you do addition or subtraction, how to do addition and subtraction means, if the matrices are compulsory, orders must be equal, then only we then comparable, or two matrices are equal, that is A is equals to B, how to equal or how to find their elements means if their orders must be equal, then only we find some difference. So their orders must be equal. So take two matrices are comparable if and only if their orders must be equal. That means if we take A is equals to order M by M and B is equals to B is order P by Q, they are comparable matrices if and only if the rows of first matrix is equals to rows of the second matrix, number of columns of the second matrix is equals to number of columns of the second matrix. So that is M is equals to B, M equals to P and N equals to Q, then only two matrices are comparable. That is, observe here, if you take one example, A to C B, this is matrix A, is equals to 1 P 0 2 or 0 6. Observe here, these two matrices are equal. If they comparable means compulsory their orders must be equal. Then only two matrices are comparable. But also we find the values. That means A is equals to clearly A value will be 1. Here two matrices are comparable. Why? Because here order is 2 by 2. Number of rows here 2 and here also number of rows 2. Number of columns here 2. Here also number of columns 2. So order is 2 by 2. This is all order is 2 by 2. So orders must be equal. Then only be comparable. So A value clearly 1 and P value clearly 2. P value how much? 2. C value 0 and B value 6. If orders must be equal, then only we compare. Otherwise, not at all compare. If you take order 3 by 2, not comparable matrices. So two matrices are said to be comparable matrices if their orders must be equal. Then only two matrices are comparable. That is, M is equals to P and N is equals to Q. Next, equality of two matrices. Equality of matrices means equality of matrices are equal matrices. Equality of matrices means two matrices A and B. Two matrices are said to be equal matrices. Two matrices are said to be equal matrices. Two matrices are said to be equal matrices. Two matrices are said to be equal matrices or matrix if their orders must be equal. If their orders must be equal and their corresponding elements are also equal. Equality of two matrices or equal matrices means two matrices A and B or two matrices are said to be equal matrices. Their order must be equal. Their order must be equal and their corresponding elements must be same. That is, must be equal. So two matrices A and B are said to be equal matrices. Their order must be equal. And their corresponding elements also must be equal. Then only two matrices A and B are said to be equal matrices. For example, if you take A is equals to A is a order M by M and B is equals to B is a order P by Q If you take my matrix A is equals to A is A, order M by L, another matrix B matrix that is B is A, order B by Q, this is B by Q. Both are equal matrix if that is if A is equals to B, A is equals to M by L matrix and B is equal to B is A, P by Q matrix. They are equal. They are equal if and only if they are equal, if and only if their order must be equal, their order must be equal. That means M is equals to compulsory P, and second one is N is equals to Q. Orders must be equal, and third one is A is equals to B is A. A is the element A is equals to compulsory corresponding element. A is equals to compulsory, B is the element for I comma Z, for all I comma Z. For all I comma Z, A is a value is equals to B is A. For all A is a value, A is a print, A11 is equals to B11, A12 is equals to B12, A13 is equals to B13, A21 is equals to B21, A22 is equals to B22. So if I say element is equals to B I say, so for all I comma Z elements. So two matrices are equal matrices. Two matrices are said to be equality of matrices. Equality of matrices are equal matrices. Two matrices are said to be equal matrices if their corresponding elements equal, and their orders must be equal. Their orders must be equal and their corresponding elements also equal. Observe here, this is two matrices, equality of matrices. If matrix A, this is matrix B. Two matrices are equal, then only corresponding elements equal. If you take this example only, corresponding elements equal. A is equals to, orders must be equal. M is equals to P and N is equals to Q. Orders must be equal and corresponding elements also equal. That means A is equals to 1 and 2 is equals to P. And C is equals to 0 and B is equals to 6. So corresponding elements must be equal. And orders also must be equal. Then only two matrices A and B are said to be equal matrices. Equal matrices. Or take for example, A is equals to X plus 1, A is equals to X plus 1 and 2 and 0, 3 and B is equals to take 0, 2, 0, 3, 0, 2, 0, 3. If A is equals to B, then value of X. A is equals to X plus 1 to 0, 3 and B is equals to 0, 2, 0, 3. If A is equals to B, then find the value of X means, observe here, order must be equal. This is 2 by 2 matrix, this is also 2 by 2 matrix. Orders are also equal and equal matrix means they corresponding elements. X plus 1, corresponding element here 0, 2, 2, 0, 0, 3, 3. Corresponding elements must be equal. Then only two matrices are equal. So here they gave two matrices A and B are equal. How to find the value of X means X plus 1 value. Here the corresponding element. This is A11 element. A11 element compulsory is equal to B11 elements. So X plus 1 is equal to how much? Here X plus 1 is equal to 0. If you transfer plus 1 from LHS to RHS, it becomes minus 1. So X will clearly minus 1. What is the value of X means? Here X value how much? Minus 1. So two matrices are equal. Or equality of two matrices means their order must be equal. Their orders must be equal and their corresponding elements also equal. Then only two matrices are said to be equal matrices or equality of matrices. Yes. How to add the two matrices? That means sum of two matrices are addition of matrices. Sum of two matrices are addition of matrices. Let us discuss. Sum of matrices are addition of matrices. Observe here. Sum of matrices Addition of matrices. Yes. Sum of matrices or addition of matrices means, let A and B are the two matrices. Let A and B are the two matrices of the same order. Let A and B are the two matrices of the same order. And their sum is defined by A plus B is a matrix of the same order, and each element, the sum of the corresponding elements of A and B is called the addition of the matrices. Now let A and B are two matrices. Let A and B are the two matrices of same order. Let A and B are the two matrices of same order, and their sum is defined by, A plus B, and the sum is A and B are the two matrices of same order. Order must be equal. Two matrices of the same order, and their sum is defined by A plus B, and their sum is defined by A plus B of matrix of same order. That means if matrix order is M by N, and this matrix B matrix order is M by N, and we get A plus B matrix also M by N only of same order, in which each element is the sum of, matrices sum of the corresponding elements of corresponding elements of A and B. Observe. Let A and B are the two matrices. Two matrices of the same order. Order must be equal. Let A and B are the two matrices of the same order, and their sum is defined by, or their sum is denoted by A plus B, and their sum is denoted by A plus B. A plus B is also one matrix of the same order. And each element, in which each element is the sum of the elements of corresponding elements of the A and B. That means if A is equals to, A is a M by N order. Observe here. Let A is a matrix of M by N order, and B is the matrix, B is of M by N order. Orders equal, and their sum is defined by or denoted by A plus B is equal to some variable Ci is M by N. A matrix order M by N, and B matrix order also M by N. So A plus B means we get same order, that is M by N. Where Ci is nothing but A is A. That means corresponding elements of A and B. The sum of the corresponding elements of A and B, that is Ci is equal to A is A plus B is A. This is called what? Sum of the matrices or addition of the matrices. Sum of the matrices or addition of the matrices. Let us discuss some small one example. Observe here the example. Let A is equals to 2, 3, 0, 6, 9, 7, and B is equals to, take another, -1, 5, 7, 0, 6, 8, 0, 6, 8, Find A plus B. Observe here, the matrix order is clearly how many rows? 1, 2 rows and 3 columns. So order is clearly 2 by 3. Here matrix B order also 2 by 3. Matrix A order 2 by 3 and matrix B order also 2 by 3. So we want A plus B. A plus B means what? Sum of the two matrices. Sum of the two matrices is nothing but the sum of the two matrices is defined by A plus B is the matrix of same order and each element is the sum of the corresponding elements of A and B. Sum of the corresponding elements of A and B. That means we want A plus B. A plus B we want. Observe here. A plus B is the matrix also same order and each element is the sum of the elements corresponding elements of A and B. That means A plus B means here 2 corresponding element is clearly minus 1 in the order same order. So A11 element first column element here 1 2 here first column element is minus 1. There is sum B1 that is 2 minus 1 2 plus of minus 1 then 2 plus of minus 1 2 plus of minus 1 and first row second column element is 3 first row second column element is 5. We want their sum that is 3 plus 5 and first row third column element is 0 here in B matrix 3 first row third column element is 7. We want their sum 0 plus 7. Also second row first column element is 6 here second row first column element is 0 here. We want their sum clearly 6 plus 0 and second row second column element is 9 and second row second column element is the B matrix is 6. We want their sum that is 9 plus 6. Second row third column element is 7 in the matrix A and second row third column element is 8 in matrix B. So we want their sum that is clearly 7 plus 7. Observe here we have A plus B is equals to 2 plus of minus 1. That means minus into plus minus 2 minus 1 means we get 1. 3 plus 8. 3 plus 5 clearly 8. 0 plus 7 clearly 7. 0 plus 7 is nothing but 7. 6 plus 0 6 only. 9 plus 6 15 and 7 plus 8 15. This is order we get same order. This is 2 rows and 3 columns. This order also 2 by 3. This order 2 by 3. This order also 2 by 3. So A plus B order is also 2 by 3. This is. So observe here, if you let A and B are the two matrices of the same order, let A and B are the two matrices of the same order, and their sum is defined by A plus B. Defined by A plus B is a matrix of same order, and each element is the sum of the corresponding elements of A and B. Each element is the sum of the corresponding elements of A and B. Sum of the corresponding elements of A and B. This is addition of two matrices. Let us discuss properties of addition of matrices. 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 Properties of addition of matrices means let matrix A is A and B is let matrix A is equals to A is A and B is equals to matrix B is A and C is equals to matrix C is A of same order. In B matrices of the same order with the matrices of same order with the matrices of the same order. Matrix A and matrix B and matrix C or with the matrices of same order. Then the addition of matrices satisfy the following properties. Then then the addition of matrices, then the addition of matrices, then the addition of matrices satisfy following properties. First one, that is first one. Addition of matrices satisfy the following properties. First one, that is commutative property. Commutative property. Commutative property. Commutative property means addition of matrices satisfy commutative property. Addition of matrices is commutative. Addition of matrices is commutative. That means addition of matrices is satisfy commutative property. That means A plus B is equals to B plus C. Sum of the two matrices, that is A plus B is equals to B plus C. Addition of matrices. Addition of matrices is commutative. Addition of matrices is commutative. Addition of matrices is commutative means A plus B is equal to, observe here, A plus B. A plus B means clearly A matrix is Aij of the same order and B matrix is Bij. So Aij plus Bij, we get a matrix of the same order, that is C. That is, we get Aij plus Bij. Already we know that A plus B is equals to B plus A. So this can be written as our convenience, that is Bij plus Aij. If you separate these elements, we get Bij plus Aij. So A plus B is equals to, we get B plus C. A plus B is equals to, we get B plus C. So commutative property. Addition of matrices is commutative. Addition of matrices is commutative means it satisfies the commutative property. That means A plus B is same as B plus A. A plus B is same as B plus A. That means addition of matrices is commutative. Addition of matrices is commutative. Yes. Next, associative property. Associative property. Second one. Associative property. Associative property. That means matrices obey associative property. That means our matrices are satisfied by the associative property. Matrices are, addition of matrices are, addition of matrices are obey associative property. Addition of matrices are obey associative property. That means addition of matrices are satisfied by that is associative property. That means A plus B plus C is equals to A plus B plus C is equals. Already we know that A means clearly A is a matrix and B plus C, that is matrix Bij plus C means matrix Cij. A plus B plus C is equals to. So this can be written as Aij plus, this is Bij plus Cij. This is, their sum is clearly, their sum is Aij plus, this is small b, this is small b. Aij plus Bij plus Cij. This can be written as Aij plus Bij plus Cij can be written as clearly, that is Aij plus Bij plus Cij. So Aij plus Bij is nothing but Aij plus Bij. This can be written as Aij plus Bij plus Cij. That means Aij means clearly A, A plus B plus C. A plus B plus C. Observe here. Observe here. A plus B plus C. A plus B plus C is equals to, we get A plus B plus C. A plus B plus C is equals to A plus B plus C is equals to, we get A plus B plus C. That means matrices are obeying associative property. Matrices are satisfied by the associative property. That is A plus B, A plus B plus C. A plus B plus C is nothing but A plus B plus C. A plus B plus C is equals to nothing but A plus B plus C. That means matrices are obeyed by the associative. Next one is additive identity. Next property. Additive identity. Additive identity. That means if A is a m by n matrix, let A is a order m by n matrix and O is a or 0 is a null matrix of order m by n, and A is a any matrix order m by n, and O or 0 is a null matrix. 0 is a null matrix, or O is a null matrix of order m by n. 0 is a null matrix of order m by n. Then A plus 0 is equals to 0 plus A is equals to A. It will satisfy this condition. This is matrix plus null matrix. Null matrix plus matrix is equals to, we get matrix only. So it will satisfy this condition. A plus 0 plus 0 plus A is equals to A. So this is 0 is called, or null matrix is called the additive identity of all the m by n matrices. So it's let of the order m by n. Then A plus 0 is equals to 0 plus A is equals to A. So here null matrix 0. That means null matrix here. Null matrix of order m by n is called the identity of all the matrices, identity of all the m by n matrices. That means matrices have additive identity. That means A plus 0 is equals to 0 plus A is equals to A. Here 0 is clearly null matrix of order m by n. So here 0 is called the additive identity of all the m by n matrices. Observe here, if A is equals, for example, if A is equals to 2, 3, 4, 7, and we want A plus 0 is equals to 0 plus A is equals to A, we want. Observe here. 0 is a null matrix of this order is 2 by we take 0, 0, 0, 0, 0, 0, 0, 0. We want A plus 0. A plus 0 is equals to A plus 0 means 2 plus 0. We get 2 plus 0, 3 plus 0, 4 plus 0, 7 plus 0. 7 plus 0. That means we get 2, 3, 4, 7. That means A plus 0 is equals to 0 plus A is equals to A. So here null matrix 0 is called the null matrix or 0 matrix is called the additive identity of the all the m by n matrices. Additive identity of all the matrices. So additive identity of the matrices is clearly null matrix or 0 matrix. Null matrix or 0 matrix is called the additive identity of all the matrices. So additive identity of all the matrices is null matrix or 0 matrix. It's additive inverse. Next one, fourth one. Additive inverse. Let A is the matrix. Let A is the matrix of order m by n. Let A is the matrix of order m by n, and there exists unique matrix, and there exists unique matrix. A is the matrix of order m by n, and there exists unique matrix of order m by n, of order m by n, mat B of order m by n, matrix B, that is of order m by n, matrix B. That A is the matrix of same order, that is m by n order, and there exists a unique matrix of order m by n, matrix B, such that A plus B is equals to B plus A is equals to A plus B is equals to B plus A is equals to 0. A plus B is equals to B plus A is equals to 0. In this case, B is called the additive inverse of given matrix. Additive inverse of given matrix. Observe here, let A be the any matrix of order m by n. There exists unique matrix of order m by n. There exists unique matrix of order m by n, that is matrix B, such that it satisfies A plus B is equals to B plus A is equals to A plus B is equals to B plus A is equals to 0. Then here B is called what? B is called the additive inverse of the matrix. So let A is equals to matrix. A is equals to matrix. A is A. Then additive. Additive inverse is that is B is equals to clearly minus Aij. So A is the matrix of order m by n. Then additive inverse B is equals to minus of Aij. Minus of Aij is called the additive inverse of the given matrix. Let us discuss for example here. If A is equals to 3, 7, minus 3, 4, 3, 7, minus 3, or minus 2, or minus 8, 4, 3, 7, minus 8, 4, we want find additive inverse of A. Additive inverse of A. Clearly, additive inverse of A is clearly minus A. We want clearly minus A. That is minus times of 3, 7, minus 8, 4. 3, 7, minus 8, 4. That means additive inverse. A plus B is equals to B plus A is equals to how much? 0. A plus B is equals to B plus A is equals to how much? 0. So additive inverse is we get minus 3, minus 7, and plus 8, minus 4. Minus 3, minus 7, minus 4, and plus 8 and minus 4 is the matrix B. We get, observe here, otherwise we get here A plus B. A plus B is equals to 0. A value clearly already we know that A value 3, 7, minus 8, 4, 3, 7, minus 8, 4, plus B is equals to 0 means null matrix, clearly null matrix. We want matrix B. Matrix B is equals to clearly 0, 0, 0, 0, minus 3, 7, minus 8, 4. So we get clearly 0 minus 3, 0 plus of minus 3. Addition, subtraction of the matrix also. So 0 minus 7, 0 minus 3, we get minus 3. 0 minus 7, we get minus 7. 0 minus of minus 8, we get plus 8. 0 minus 4, we get minus 4. This is the additive inverse of the matrix. That means it will satisfy A plus B is equals to B plus A plus B is equals to B plus A is equals to 0. Then the matrix B is called what? Additive inverse of the matrix. So let A is the any matrix of order m by n. There exists unique matrix B of order m by n that it satisfies A plus B is equals to B plus A is equals to 0. Then B is called what? Additive inverse of the matrix. Next one. Differences of your matrices. Differences of your matrices. So let A and B are two matrices of the same order. Let A and B are the two matrices. Let A and B are the two matrices of the same order. same order. Let A and B are the two matrices of same order, and the difference, and the difference is defined by or denoted by A minus B is a matrix. A minus B is a matrix. So that A and B are the two matrices of the same order, and their difference is denoted by A minus B is also a matrix of same order. A minus B is a matrix of same order. Matrix of same order in which each element is the difference of corresponding of A and B. In which each element is the differences of in which each element is the differences of corresponding elements of A and B. That is differences of two matrices. Differences of two matrices is denoted by A minus B is a matrix of same order. That means A and B are any two matrices of the same order. This is order is M by M. B matrix are also same order B M by M. Then only differences exist. Otherwise, difference is not exist. Addition also, if the A and B are the two matrices of the same order, then addition is exist. Otherwise, addition is not exist. If you take A is equals to 2 by 3 order and B is equals to order 3 by 2, their difference or their sum does not exist. So A and B are clearly two matrices of the same order. Then their difference is denoted by A minus B is a matrix of the same order. Then each element, so that in each element is the differences of the corresponding elements of A and B. Observe here. Let A is equals to A is A and B is equals to B is A, and then A minus B is equals to clearly A is A minus B is A. A is A minus B is A. A is A minus B is A. We get clearly C is A. C is A means where C is equals to each element A is A minus B is A. A is A minus B is A. We get C is A. This is the difference of the two elements. Let us discuss one example here. If A is equals to 1 to 7, 8, 1 to 7, 8, and B is equals to minus 3, 5, 2, 4, minus 3, 5, 2, 4, then find A minus B. Then find A minus B. We want A minus B. A minus B is the difference of the two matrices A and B. Their difference is denoted by their difference is also matrices A minus B. This is the each element, in which each element is the differences of the corresponding elements of A and B. That means A minus B is equals to we get 1 minus of minus 3, 2 minus of corresponding element, 2 minus 5, 7 corresponding element is minus 2, 8 corresponding element is minus 4. So that is equals to 1 plus 3 we get 4, 2 minus 5 we get minus 3, and 7 minus 2 we get 5, and 8 minus 4 we get 4. This is the difference of the two matrices. Differences of the two matrices is denoted by that A and B are the two matrices of same order. Their difference is denoted by A minus B is a matrix of order same order in which each element is the differences of corresponding elements of A and B. This is differences of elements of corresponding elements A and B. This is called what? Differences of the matrices. Next.